Hello and welcome to my class, to my video class today. So in this video, and not necessarily just today, we're going to study what a statistical test is, how to formulate a hypothesis test, and how to interpret the results from a statistical test. So you must have heard, for example, what is the null hypothesis and what is the p-value and what should I conclude. Um, it's probably like a foreign language at the moment for you, but I'm going to explain maybe with some examples in this video so that you could understand more what is meant behind it. It is a very, it's a kind of difficult notion at the beginning of doing any statistics or any studies involving statistics. So I will try to make it as simple, as much simple as possible, and take your time to digest. Of course, just watching once this video is not enough to understand what is behind this notion of hypothesis testing and this notion of p-value. So we're going to have a look at this right now. So we do what we call inference about a population from a sample. So in any statistical studies, you will study something like from a population in general, a general population that you cannot have, you cannot measure the entire population basically. And so you will have to take a sample from that population in order to conclude from the big population. The sample will be a summary of your population because you cannot measure all the population. For example, here, the research question is, what is the mean weight of the human population? We want to study the mean weight of the 7 billion humans living on this planet. 7 billion or 8 billion, I don't really remember how many we are. The population is general, is the set of the 7 billion humans, okay? A sample from the population would be a subgroup or little group taken from that population. For example, a group of 1,256 people. So out of this sample, we will collect the mean weight of this sample, this group of people, and see what is the mean weight, and to have a clue about the mean weight of the 7 billion humans living on this planet. We do, in that case, an inference. So it's a nice word to say that basically you collected a sample, you computed the mean, and you conclude about the population. In that case, we say that we infer about the population from a sample. You must have heard also of the name inference, okay? At the moment, inference is not really the important word to know about this video, but it's just in case, you know, you might want to know what an inference is, what inference means, sorry. So a sample, as I say, is a little part of the population, okay? As I just mentioned, it is very rare to get the data of all the individuals. You will not like measure the weight of all the population in the world. It's too expensive, too much time consuming. It would take like many years. And in general, this is what happens in studies, okay? In polls or scientific research, you are never able to survey everyone in the population or collect the data from an entire population. Sorry. Instead, we sample from the population, and from the sample we can calculate numerous statistics such as the mean, the proportion of yes in a referendum, and conclude about the population. So for example, actually the political polls, for example, we would take a sample of 1,000 people and not the entire population of a country, okay? A country as big as Brazil, for example, like 200 million people. I'm not sure of the population, the total population of Brazil. Sorry if there are some Brazilians watching this video, but it's something like this. So you would not like ask this 200 million people living in that country. You will not ask what they think about this policy or what they would vote for in the next election. You will ask only 1,000 people of the population, or 2,000, okay? After that, the number of people you ask in the sample is a good question to know. So this will be in a later video when talking about the power of of a statistical test, this will be the question of how many individuals is how big should be my sample in order to make my test or my statistical analysis reliable. Okay, so this would be the topic of the next video about the type 1 and type 2 error and the power of a statistical test. Okay, at the moment in this video it's just about inferring about the population from a sample using the p-value and some guidance about how to analyze statistical study. Okay, this is just the objective of that video. After that, we will learn how many observations do I need in my sample or my samples when comparing different populations. We will see after. So how many observations I need in a sample, this will be the topic of the power of a statistical analysis. Okay, so we need, of course, to sample correctly, okay, provided that we have a number of observations in our sample. We need the sample to be random and not biased as much as possible, okay? In the newspapers or anything, you may read statistical studies, so, but we don't, so the results, the means, the medians, etc. that they give is true, but the way they have sampled their groups, like they have sampled their population, might not be good. We don't know, okay? Some of them are honest, some of them are not honest. Okay, for example, in election polls, you will not only sample the political choice of people living only in rich suburbs, or only the political choice of people living in very poor areas, okay? You will have to make it as much random as possible, okay? In our example of mean weight of the human population, we will not only get our sample from one continent specifically, okay? We know that in this part of the world, people are likely to be smaller. In general, they are smaller. So you will not only sample from that part of the world, okay? You need to sample more randomly across the regions, continents, etc., etc. I took the example of the world because it's a massive population, and then it can give you an insight of what population is and what a sample is. Our sample is constituted of only, it's composed of only 1,256 individuals. It could have been 2,000. It's just, I made up that number, to be honest. So in order to answer a statistical analysis, when it's about showing the mean, what is the mean of that population? So a continuous variable, as I mentioned in my first video, a continuous variable, we want to know about the mean of a population. You will do what we call a one sample t-test. I will give you a table of statistical tests just after this last explanation, and in which you will see what test you should use when you want to compare the mean with the hypothesized mean, or what test you should use when you want to compare two populations or three different populations. The mean between two or three different populations is the mean different from population A, from population B, so on. Here we are interested by the mean in general of the population compared to one value. So the question at the beginning is, what is the weight of the human population? But if you want to analyze it statistically, unfortunately, you will need to find like what we call the hypothesized value, a theoretical value that you want to know if the mean of the population is close to that hypothesized value or not. And for this, you will need to pick up a sample from the population. So a sample of 1,256 individuals, for example. You compute the mean M equal to 63.5 kilograms, and then you compare with the hypothesized mean of the population, okay? The mean mu of the population is in practice unknown because you cannot collect all the population, as I said. So the Greek letters are anything related to the population, anything theoretical, okay? So the mean weight of the world population is mu. That's something we don't know. The Latin letters or the English letters are anything related to any sample or data that we can really obtain. Anything empirical, anything concrete that you can have on the table. Mean weight of the sample is m, okay? That we can get it because we can measure the sample that we collected from the population. Statistical tests are all about verifying or rejecting a hypothesis that we call the null hypothesis. That hypothesis gives some value or insight about the big general population. So in order to answer to that question or what is the mean weight of the population, of the world population in general, you need to create a hypothesized mean, okay? So a hypothesized mean of 62.3 kilograms. Unfortunately, you will have to check, is the mean of the population close to that value of 62.3 kilograms? Okay, so you will need to know in that case an order of magnitude that you want to verify. Is my population far away from 62.3 kilograms? In that case, you can conclude that indeed, so if the mean, for example, of the sample that you have taken was 70 kilograms, so the mean of the 1,256 humans taken is 70 kilograms, you can conclude that we are far off from H0 and you would reject H0. You have found a contradiction with H0. So H0 is that the mean of the population mu, that is impossible to collect, is equal to 62.3 kilograms. You need to pick up the sample and from that sample to either reject that null hypothesis because you have found a contradiction, you have found a mean m Latin letter because it's the sample, that's what you can really have, is 70 kilograms, you conclude that you are far from H0. So you have found a contradiction with H0. If the sample mean of this sample had been 62 kilograms, 62 kilograms is close to the hypothesized mean of your null hypothesis, so there would not be enough evidence against H0. Okay, and in that case you would not reject H0. All right, so remember the null hypothesis is about the population. Okay, so here we want to verify that if the mean of the population is equal to 62.3 kilograms, we want to know if we reject this or if we don't have enough evidence to reject it, which probably means that the mean of the population is close to H0. So the collected sample is the data available that will allow us to conclude if we are far off from the hypothesis about the population. In that case, we say that we have found a contradiction with H0, or if we are close to it, there is not enough proof against H0. Okay. So in any statistical test, you will have the p-value. So the p-value is what you should know at the end of the video. The p-value is the probability that we reject H0 incorrectly. If the p-value is big, it means you take too much risk to reject H0 wrongly. If the p-value is small enough, it means that you take little risk in rejecting H0 incorrectly, so you can go ahead and reject H0. This is what it means, okay? Why do we use this p-value? It's because in reality it is not as easy as to check if the sample mean is close to the hypothesized mean of the population. Other factors play a role in determining if we have to contradict H0 or not, such as the spread in the data, for example. Indeed, if you had found a mean of 70 kilograms, okay, it is far from 62.3 kilograms, so you would likely reject H0. But if the spread, the standard deviation, which I'm talking about in the video about descriptive statistics, is if the standard deviation had been 10 kilograms, it means that it is the data, the sample had been would have been very heterogeneous, like a lot of extreme values. You would have people with 85 kilograms as weights and people with 55 kilograms. In that case, the 70 kilograms is maybe is the mean of the sample, but the spread around the mean is large, and in fact, a lot of people would be close to 62.3 kilograms in that sample, and in that case, you would not reject H0. So it's not as simple as getting the mean. You need to take into account the spread in the sample, and all this, the spread, the mean, the number of people in your sample is taken into account in the p-value. In general, the threshold of how small the p-value should be in order to reject H0 is 5%. So if you have a p-value of 4%, it means that the probability that you would reject H0 incorrectly is only 4%. So you take little risk in rejecting H0 by mistake. You just take 4% of risk of rejecting H0 by mistake, okay? So you can go ahead and reject H0. And that 5% is the significance level, okay? That you must have heard of a lot, okay? This is the maximum risk of making a type 1 error, that is rejecting H0 incorrectly, which I will talk about in my next video about the type 1 and type 2 errors. So remember, if the p-value is small, is less than 5%, you reject H0 about the statistical analysis. With the p-value, we can only prove the contradiction in H0. That's an important point, okay? But we cannot prove that H0 is true, okay? If you have a great p-value, it doesn't mean that H0 is totally true, that the mean of the population, of the world population, is 62.3 kilograms. You can only make a proper conclusion of rejecting H0 if the p-value is less than 0.05, okay? Is less than 5%, okay? 0.05 is 5%, okay? The p-value, you will see it either as a number between 0 and 1 or a number between 0% and 100%, okay? If you see it in the decimal format, like 0.05, you multiply by 100, you get 5%. I forgot to say this, sorry. So if the p-value is greater than 0.05, you should not say that we accept H0. You should not say that the mean of the population, the weight mean of the population is 62.3 kilograms. What you should say is that there is not enough proof to reject H0, okay? I know that for a lot of us, we will say in our mind that, okay, we accept H0. But on the paper, on the report, on the research or the work that you're doing, just say there is not enough proof to reject H0. It's a bit like in a trial when you want to know if somebody is innocent or guilty. That person is, first of all, innocent. H0 is that the person is innocent. Because this is always like this anyway. When you arrest somebody, you have the right to be innocent at the beginning, okay? You're innocent. Then you try to find proof or evidence against that somebody. Well, you may find no evidence, and in that case, you do not reject H0. You don't have enough proof to conclude that the person is guilty. So in that case, just to summarize, H0 is the person is innocent. The opposite of H0, what we call the alternative hypothesis, is the opposite of H0. It means the person is guilty, okay? You will find either enough evidence to reject H0, so to prove that the person is guilty, okay? Or you may not find enough evidence to prove that that person is guilty. In that case, you can conclude and you will see, you will like free that person, okay? But you will not have proven entirely that the person is totally innocent, okay? A statistical test we have used as an example here is called a one sample t-test. But you have many statistical tests out there. This is just the example where we compare the mean weight we want to know. So basically what we are doing is comparing the mean of one population, here the world population of the human beings, okay, with a hypothesized value, okay. You will always need like a hypothesized value in a one sample t-test, okay. You will not have like a statistical test that says, oh, the mean of that population is this, okay? It's not this. In one sample t-test, you need to create or to know about a hypothesized value. And based on the sample t-test, the one sample t-test, you will know if that value is feasible or not, okay? So there are other statistical tests, such as the mean of, comparing the mean of two populations. So in that case, you would do an independent t-test. I have created like a table, a non-exhaustive table of several statistical tests. Of course, these are not the only tests that we have, but these are the main ones you should know at the beginning. I haven't put the non-parametric tests yet, okay? At the moment, we are only looking at parametric tests, and I will explain parametric and non-parametric tests in later videos, but later videos because I will repeat throughout different videos. So what we did is the first row at the moment. The research question is the population mean equal to a certain value? The null hypothesis in that case is the mean of a population is equal to a certain value, what we call the hypothesized value. The mean of the population, remember, is the Greek letter mu, okay? So the descriptive statistics that we use are in general the mean and the standard deviation, but you can add others. It's just like the essentials that you should use are the mean and the standard deviation. The graph is the box plot. The graph that you should use is the box plot. We will see that in the next video about descriptive statistics. So actually like a video about my video about descriptive statistics. We will check what the mean is, the median is, the box plot, and so on in the video about the descriptive statistics. And based on that video, you will, and based on that table, you will know what to do with which research question you should, which descriptive statistics you should deal with when you have such and such research question. The test that you have to do for that first row, so answering the question, is the population mean equal to a certain value, is a one sample t-test. Okay, this is what we did. We want to verify if the mean of a population is equal to a certain value. You will get the p-value. If it's less than 0.05, you reject the null hypothesis. So it means that you conclude that there is a significant difference of the mean of a population compared to that certain value. Okay. But you have other research questions you may have, of course. It's not just about the one sample t-test. To be honest, I never use the one sample t-test. It's just like the basic test that we learn at the beginning. It is a bit maybe complicated to understand at the beginning. Maybe you will understand more about the p-value and so on by doing independent t-tests and practicing and so on. I'm not sure, but usually we first show what a one sample t-test is. What you can do in the future is, for example, comparing two populations, A and B. The mean of a population A, the mean of the population A is equal to the mean of the population B. In that case, that would be the null hypothesis. The null hypothesis is, in general, the neutral hypothesis, when nothing happens. So the question, you may be interested by finding that there is a difference between the two populations, but you may also be interested to know if there is no difference, okay? You may be happy in either way. In your research question, sometimes you would like, you would be happy if the populations have the same mean. Sometimes you would also be happy if the populations have different means, okay? It depends on your research paper or what you want to prove at your work and so on. So it's not that you have absolutely, like the null hypothesis is the good thing or the bad thing. That's what I mean, okay? Sometimes you will want to reject the null hypothesis in order to probably, if you want to publish a paper, you want absolutely to prove that the population A is different from the population B. In that case, you want to reject the null hypothesis. But sometimes you don't want this. But there is nothing you can do. You will have your samples, and either your null hypothesis is rejected or not, okay? It doesn't matter the taste of what you want, okay? But what will always be there is the research question and the null hypothesis. The null hypothesis will be like the neutral case where nothing happens. The person is innocent, okay? So here the mean of the population A is equal to the mean of the population B is the null hypothesis for the research question, do populations A and B have the same mean? We say that we compare two populations. In that case, we would do an independent t-test. We would plot box plot or mean plot to compare the two groups, okay? Because of course you cannot measure the two populations entirely. You would only take two samples, one sample from population A and one sample from population B. You can compare more than three populations. In that case, you would do a one-way ANOVA. You can compare the change between before and after an intervention, the mean weight of a population before going to the gym, for example, and the mean weight of the population after going to the gym for 3 months, let's say. So you compare the mean before the 3 months and the mean after the 3 months. In that case, you do a pair t-test. There are just 2 times, before and after. When there are 3 times, it's a repeated ANOVA. We will see that little by little in studying the videos. Is there an association between two numerical variables, the height and the weight, for example? Well, we know that the height is related with the weight for the human population, but I mean, if you want to look for an association between any numerical variables, okay, the salary and the age, for example, the wage and the age, is there a correlation? So in that case, the null hypothesis is no correlation. You will do the test correlation coefficient, Pearson's correlation coefficient test, and you will have a p-value, and with that p-value you will reject or not the null hypothesis. If the p-value is less than 0.05, you will have no correlation. If it is more than 0.05, sorry, if the p-value, I made a mistake. If the p-value is less than 0.05, you will reject the no correlation. So it means that there is a correlation. In that case, you can say that there is a significant correlation. But if the p-value is more than 0.05, if the p-value is more than 5%, okay, you take too much risk in rejecting the null hypothesis incorrectly. So you will not have enough evidence to reject the null hypothesis. You will not have enough evidence to reject the no correlation, okay? Is there an association between two categorical variables? In that case, it's a chi-square test. So, I hope you remember what a categorical variable is and what a numerical variable is. This was the object of my previous video about what is a data set and the types of variables, okay? So if you want to look for an association between the passenger class on the Titanic, 1, 2, 3, and the survival status, 0 or 1, so these two variables, survival status and passenger class, are categorical variables. You want to see if there is an association between them, you will do a chi-square test, okay? The null hypothesis is no association between survival status and passenger class. And so if the p-value of the chi-square test, again, is less than 0.05, you reject the null hypothesis. If it's more than 0.05, you do not reject the null hypothesis. You don't have enough evidence to reject the null hypothesis. So if you reject the null hypothesis with a p-value less than 5%, it means that there is a significant association between the passenger class and the survival status. We will do a chi-square test later in R, with R, the software R, and check, I mean, not in this video, but in a later video about the chi-square test, and check if there is an association between categorical variables, okay? To summarize, in a statistical analysis, you should formulate what a research question is the height mean different between men and women? Then you need to formulate your null hypothesis, absolutely. You then explore the descriptive statistics and graphs to know more about your data. You choose the statistical test. So in that case, the research question in that slide, the example is the height mean different between men and women? So H0 would be the mean, the height mean of the men is equal to the height mean of the women, so in the population in general. Of course, you will sample from these two populations and explore the descriptive statistics inside these samples. Remember, you cannot have all the population. You will choose the statistical test to prove if the population of men is different from the population of women in terms of height mean. So that's an independent t-test, okay? You compare two populations, okay, which is in that table. And you conclude with the p-value. Is the p-value less than 0.05? If yes, then you reject H0, and there is a difference or significant difference or a statistically significant difference of height between men and women. Okay? And that will be it for this lesson today. The next video we will see, so there are two next important videos that you need to watch. It's about the type 1 and type 2 errors with the power of a test in order to be able to know if the number of observations that you have in your sample is enough. You will need to go through the power of a test. You will see that it's not like a very simple notion either. After that, we will see in another video, of course, the descriptive statistics. So what graph you should use based on the type of variable you have. But before doing this video of descriptive statistics and graphs, before watching this video, sorry, you need absolutely to go to the what is a data set and type of variable video, the video 0, okay, that I have put on my channel. Before doing the type 1 error and the type 2 error, it is better to go through this video about hypothesis testing and interpretation with the p-value. Okay, so with these 4 videos, you can, these are the basics of statistics, and I will show like a summary of the different videos, the contents of the videos. Basically, we are seeing the basics that are important, but that you will always go back to. Okay, when you have a statistical test, you don't remember exactly what test you should do. You go back to the basics where there are all the tables of all the tests, all the different tests. After all the statistical tests and so on, we will see also some machine learning techniques and so on. But they all use like the same notions with the p-value, like descriptive statistics, and everything will become easier as you go back and forth to the basics, okay, and to what you are currently doing. Okay, so I will say to you that I hope you enjoyed the video. There is my email in the comments. If you want to contact me, please do not hesitate. I'm happy to answer any question you may have. And thank you very much for your attention. Okay, see you soon.